Let's start the session early today so that remaining people will join tomorrow very fast. Right? Let's at least wait for 9:05 till. Okay, so let's start the session. So, okay. So here what I can simply do, so here we do have the API gateway. So previously we are working on this particular scenario, right? So here we do have the application.yaml, and here we do have something called a bookings API, which will reroute our request to the booking service directly. Correct? So what we can do now over here, so since let me start the API gateway first of all, along with Eureka server. So let me start this movie services registry application. And let me start the API gateway. and let me start the booking service also. So raise your hands at the end of the session, not in between. Okay. So today I think I will clarify most of your questions and we will see how it actually works. Okay. So now we do have the movie services registry application, we do have the API gateway, and we do have the booking service application, correct? So now what I can simply do, I can just go to this one and I can just access the localhost 8765. So let me access this 8080/bookings. So here, if I just go to this booking service APIs, so I have just given, so let me define a simple test endpoint to test whether it is actually calling or not. So accept test. I can simply use @get mapping, and here I can simply use /test. Okay. So return. Okay. So now I just wanted to stop this booking service and restart this application again. Okay. So now everything is started. Now we can actually go to this and we can hit our test endpoint. So 8080 is the bookings API. It's not the bookings API. So I think let me start this on 8081. Yeah. So I think let me start this one. Terminate. I think this booking service application, right? This is 2. So let me remove this first of all. Delete it. Yeah. So now there is a booking service application which is running on 8080 port. Okay. So let's see what happens now. Okay. So now I can just call this and this booking API is being called, right? So this is the port of the booking service directly. When I use 8765 and say bookings/test, then we are actually getting 404. I will tell you the reason why. Okay. So here there are so many changes done for the Spring Cloud API gateway. So if you just see the dependency over here, there's something called Spring Cloud Starter Gateway MVC. So do you know what is the meaning of MVC? So M stands for model, that means data. View stands for some view pages. Right now we are not using any view pages, and these are the control options using the controllers approach. So I don't want to define this. I just wanted to define Spring Cloud Starter Gateway. Okay. Now if I just click on this, reload. And now let's start the application again of the API gateway because the dependency has been changed. And if I just restart this application, the Spring Cloud Starter Gateway should be used for our Spring Cloud API Gateway implementation and for the routes. Okay. So now we'll just understand how it is actually working behind the scenes. So now if I just hit this one, just wait for some time. It is actually loading. This is continuously loading. Wait for some time because it has to register with Eureka server and then it has to do this one. Yeah. So now if you can see that there is something called internal server error 500 status. What does that mean? Right. So if you just go to this bookings route, right? So we have actually defined our HTTP, but here we have to define our thing, something like load balancing feature, and then probably we can proceed with this. Okay, so now let's stop the application and rerun the application. Okay, so now the API gateway has been started. Can you see this? So only LB will work over here, not the HTTP. I will tell you each and everything. Don't worry about this. Okay. So now what happens? So if you just see here, booking API called. Okay. So now I will tell you the how this request is getting handled by the API gateway. So since 8765 is the API gateway port of this application, and now we can see that the bookings forward slash test is already there. So let's say this is the 8765, which is the port of the Spring Cloud API gateway. So when it actually sees this forward slash bookings, right? So inside the Spring Cloud API Gateway application.yaml file, we do have something called a booking second route, correct? So here we have something called predicates. So predicates is a place where we are going to have, where we are going to define the booking service related endpoints. Okay. So now when this particular URL is matching with any of our predicates of our API Gateway application.yaml of the Spring Cloud Gateway routes, this predicate is actually getting matched. Now it understands that it has to call the booking service directly. That means it will just go to the booking service. It will just go to the APIs of the booking API, and it will see that, hey, bookings is there, and also there is a test. So it understands that it has to execute this particular method. Got it? So that's the total idea. But what happens if I just stop this application of the booking service? I'm just starting the booking service, stopping the booking service application directly. I'll just start this, and I will just go to this one, and I will just hit this data again, hit this URL again. And now, can you see this? So it is actually saying internal server error. What is the meaning of this particular thing? Okay. So that means if you just go to this one, the API gateway, so it is basically saying that connection refused to 8080. Okay, so the service is not up, so it is unable to connect. The connection is refused. No further information. But here we are getting it. So can we display this type of message to the end users first of all? Can you just answer my question? Could you please answer my question? Right. So we cannot show this type of error message to the end user, correct? Now, what we can simply do, we will just go to the application.yaml, and here basically I need to define some filters. So let's say when something is wrong with this booking service, or booking service itself is not responding, then probably we need to do something. So we need to apply filters. So I will just click on filters, and I will just give a name to the filter. Okay, I'm just going to give a name to the filter, and here in the circuit breaker, so I just wanted to give the arguments as well, and I can just define the name of this argument as booking hyphen route. Whatever you want to give, you can give, but here you need to provide one fallback mechanisms. Fallback URI you need to define. Okay, so here the fallback URI has to look like forward the request to the booking hyphen fallback. Okay, so now what we can simply do, we can just go to this API gateway. So this endpoint has to be available inside the API gateway. So here what I can simply do, I can just define booking API handler fallback. And here, use the same annotations, REST controller. And here I need to define public string, booking APIs fallback. And here I just wanted to define the get mapping. And inside this get mapping, I will just go and pick up that application.yaml, this one. Okay, I'll just go to this and I will define it over here and return. I just wanted to return a sample message to the end user instead of displaying this unknown message. People will not be able to understand, right? So now what I can simply do, I will just go to this one and booking services in maintenance. Booking services in maintenance mode. Please try after some time. Okay. So we do have the booking services in maintenance mode, and please try after some time. That means what happens is, if you just go to this application.yaml, let me minimize this. So here, when the incoming request is containing this predicates path, that means predicates is a place where we'll be applying the URLs of the booking service. So here I just wanted to define all the bookings APIs, because if any of the endpoint is not available, I will have to show some message to the end user that the booking service is in maintenance mode. Please try after some time. So this, if this service is unable to respond, then this filter is just going to get invoked by the API gateway, and it will see that there is a circuit breaker. I will tell you what are all the filters are available, and this is a name you can just give. It is a booking route or booking hyphen route or booking service hyphen route, whatever it is. And you just wanted to, because booking service is itself is not available, so I just have to go to the booking API handler callback, and I just wanted to return this message. So let's see how it is actually working behind the scenes now. So I just wanted to stop the API gateway and rerun this API gateway again. And let's run this, okay? Yeah. So now if you can see that there is a issue while starting the API gateway server itself, unable to find gateway filter factory with name circuit breaker. So got this point, unable to find the gateway filter factory with the name circuit breaker. So it was unable to find the circuit breaker because circuit breaker, we have not defined any filter circuit breaker, right? It has to be available. So how it is available? So if you just go to the pom.xml, I just wanted to define the one dependency, Spring Cloud starter circuit breaker resilience 4J. So once I add this, the filter is obviously available. So what I can simply do, I can just go and restart this API gateway application. And so now you can just start this application, but still the application is not going to run because it has some concerns over this Spring Cloud starter circuit breaker resilience 4J. Okay, so let me show that to you as well. The circuit breaker will not be available unless you define this name. Okay, so this is the same thing. So unable to find the gateway filter factory with name circuit breaker. The reason being, if you just see, so if I just stop this application and remove this dependency, and also if I just go back to the application.yaml, remove and comment out this filter for some period of time, and now let's start the application of the API gateway, and you will see some strange issue. See, each and every Spring Boot application is going to start on Tomcat server, right? So now let's see what happens, on which server it is getting started. First of all, we need to look into that. So we have commented out the the filter as well as the dependency. So now, can you say me on which server the application has been started? I just want responses from everyone. On which server it has started, our application, Spring Boot application? Akash, where do you see Tomcat here? See the logs properly. No one there in the call? No one is available in the call? Can you see on which server the application has been started? Can you please respond? Yes, it started on native. What is this, Akash? I thought you were very clever. Huh? It's not Eureka, it's a NetEase server. Okay, so you can see that NetEase started on port 8765. Even if you see movie services registry application, can you see this? Tomcat started on 8761, but only the API gateway is actually starting on the NetEase server. So let me explain you about the NetEase server and the Tomcat server. Okay. No, I'm not asking about port. If I ask about port, you can just tell me the port number, right? Why you are telling the service name? Huh? Okay, then fine. Okay, so let me go and tell me that. Okay, so Tomcat server is initially having a thread pool size of 200 size, right? 200 threads to serve 200 requests at a time, correct? But NetEase server doesn't have any limit. And this limit is also based upon system CPU and available cores. Do you know how to see the cores? How many cores are available in your system? There's a simple answer for it. Go to the task manager. So if you don't know about how many cores are being used by your, so here you have Aribaba. Performance, apps, startup apps, users, details. Okay, so let me open CPU directly. So here you can, I think there is a, why it is not coming here, coming for me. Yeah. So here you can see the performance. Can you see this? So right now I do have a CPU, okay? And here if you can see the logical processors. Can you see this logical processors? I do have 4 cores and 8 processors, okay? So I do have 4 different cores. Got it? So now this is where the CPU of the applications where we can see the system CPU basically. So based upon the system CPU, our applications are actually getting executed. So now let me tell you. So based upon the CPU, it can take that many number of requests. Okay. So right now, my system can take almost, 5,000 requests. And if it is getting more, 6,000, sometimes it will be blocked, but it will be able to handle that many kind of requests to us. Okay, so now what happens with the Tomcat server and the NetEase server? Okay, so let's say we are going to give 10 requests at a time to the Tomcat server. So Tomcat server will process each and every request sequentially. Okay, and these 10 requests are going to, using NetEase server, will process all the requests at the same time. That means parallel. Okay, so that's the difference between Tomcat server and NetEase server. Okay, so let me tell you one simple reason for it. If I just go to the Book My Show app, and if I just go and select the movie, where we do have some options, right? So let's say if I just wanted to select this one, and if see here, sorry, something is not right. So can you see this message first of all? Sorry, something is not right. That means what do you mean by that? So the Book My Show is acting like an API gateway, and for the theaters, if you just see the theaters, each and every theater is a service. So those theaters will have some services up and running for their particular seats. So Book My Show will actually collect those information from the theaters, and it is going to say that these are the available seats, you can book it. Okay, so this is what it is going to happen. But right now, when we are actually hitting the bookings forward /test, this this particular API gateway, even It is not handling any responses where the booking service itself is not up and running. So it has to display some message to the end user so that he can understand, right? The same way how booking service is actually displaying this error, the same way we are going to also respond with the same response message. So let's go through this one and understand what it happens. So right now, if you just comment this out, and if I just go to the API gateway, so this is not actually working with this particular dependency, right? So here there is something called the circuit breaker resilience 4J, and even if I start this application, this will never start. Okay, the reason being, since the Spring Boot application is starting on Netty server, this Spring Cloud Starter Circuit Breaker Resilience 4J is actually designed for Tomcat server and not for Netty server. Okay, so see here, it is still saying that unable to find gateway filter factory with the name circuit breaker. Okay, so now I don't want to use this library. There is some library which is something called Reactor Resilience 4J. Use this one, and it is from the same Spring Cloud package, and this is especially designed for the Netty server. Okay, now if I just refresh this and if I start my API gateway application, this will start without any issue. So let's run this application and see whether we are going to get any issues or not. All right, so this is up and running. And first of all, I just wanted to make the booking service application up and running for some period of time. And later on, we will just stop that application from our side. Okay, so now we have started the API gateway without any problem. So it has been started on 8765, updating the port to 8765 over here. And now the booking service application has also been started on the Tomcat server 8080. Now what we will do simply, we'll just go and hit this endpoint and we will see whether it is working fine or not. Just wait for some time, because let's go to this particular option, localhost 8761, and let's see. Yeah, so these are up. So it will take some time for the Eureka server to make this service available for the API gateway. So let's wait for some time and hit this API again. Can you see this? Booking API called. That means Eureka server is actually taking some time behind the scenes to make the booking API available, or the booking service available to the API gateway. Okay, so now what happens if I just stop this application of the Spring Boot, the booking service? Now let's see what happens. If I just hit this application, now you can see the booking service is in maintenance mode. Please try after some time. So what is the meaning of this? Let's go to this application.yaml and try to understand this in a bit better way. So, so our API gateway is going to call the Eureka server, right? So if I just refresh this one, so see here, the service is down. Okay, so now when API gateway is calling the booking service directly with the booking service, because it is taking the help of the Eureka server in order to call the booking service directly with the service name. It doesn't has to pass the 8080 port also, because Eureka, since API gateway is calling behalf of Eureka server, API gateway can call the direct booking service with the service name. So now when the API gateway is calling the booking service was unable to respond, and the Eureka server will say that, hey, API gateway, the booking service is down. I cannot do anything. Please handle it from your side. Okay, so now whenever this booking service is unable to respond, so this filter is getting invoked by the API gateway, and the filter name that we have given is circuit breaker. So this is basically used for fallback mechanisms. Okay, that means if the service is not available, so this circuit breaker is basically used for giving a, see, if our service is actually failing in terms of microservice, there are lots of microservices running, and if your microservice is not able to respond properly and it is down with some exception or error, then probably all the services which are dependent on API gateway will definitely fail. So it brings the whole system down. Instead of getting the whole system down of our complete architecture, we do have to handle this kind of fallback mechanisms using circuit breaker. So let me explain you what is this resilience 4J. Okay, so let me go to this resilience 4J and I'll just go to the introduction. So here, Resilience 4J is a lightweight fault tolerance library designed for functional programming. Resilience 4J provides higher order functions to enhance any functional interfaces, but you see there are four different types of services available inside the Resilience 4J. One is a circuit breaker, another one is a rate limiter, another one is a retry, and the fourth one is bulkhead. Okay, so retry or bulkhead, only three. Okay, so we can use circuit breaker to respond with our positive. See, if the application is down, okay, we cannot make all the services which are dependent on booking service is actually a dependency for the API gateway. API gateway has to call the booking service at any cost, correct? So that's the total idea. So if API gateway has to call the booking service, so if the booking service itself is not available, then we need to respond with some positive scenario instead of making the system down with some exception. So if exception is coming, then probably our call is not getting executed, right? So that's the total idea. Okay, so now if I just go to this, so since this booking service is down for the moment, so Eureka server is telling to the API gateway, hey, API gateway, the booking service is not able to respond right now. Please try after some time. So that means the API gateway has to handle the situation since it has defined the filters. So filters will be getting executed whenever the booking service is not able to respond. So whenever the booking service is unable to respond, these filters will be getting triggered. And we do have a circuit breaker where we actually provide a fallback URI. And there is something called a forward prefix. We have to use it for redirecting to some certain endpoints. Okay. And this is the booking fallback URL where we can actually have this type of endpoint only inside the API gateway. And we do have a booking API handler callback controller over here with the get mapping, and this is how it is actually going to work. Okay, so we are going to respond with this particular data, and we need to use two dependencies. One is a Spring Cloud Starter Gateway, and another one is a Spring Cloud Starter Circuit Breaker Reactor Resilience 4J, because Reactor Resilience 4J is basically designed for native server, and Spring Cloud Starter Circuit Breaker Resilience 4J is actually designed for Tomcat server. So that's the only difference. Okay. And if you have any questions, you can ask me right now. Hope it actually makes a lot of sense to everyone, correct? Okay. Sir, if payment service is down and booking service is depending on it, but booking service is available and API gateway. So in this case, how to handle this? Yeah, you have to handle that. Okay. See, if booking service is actually failing, then probably it's a responsibility of the booking service to handle that, because since API gateway is dependent on booking service, we have actually implemented the fallback mechanism, right? Using the API gateway very simply, right? But if booking service is unable to call the payment service, there has to be a fallback mechanisms also for that, right? But you can test it from your side, Akash, and let me know tomorrow. Okay, whether that API fallback is working for you or not. But try that one. And today I do have some more things to cover. Okay. So here, let's say right now we do have this resources application.yaml. So now let's say if the Eureka server is not available, how we have to define the URI? Can anyone tell me about this? If Eureka service is not there for API gateway and the booking service, what kind of a line I can define in the URI? If Eureka service is not there, this is just to answer Suresh's question yesterday. Okay. So if Eureka service is not there, how I can actually define the URI? Come on, guys. It's very simple, right? Where booking service is actually running. Suresh, can you answer this? If Eureka service is not there, or if Eureka server itself is not there, then probably what URI that I need to define it over here? Yeah, based upon yesterday discussion, I am asking.
Yeah. The Eureka server is running on localhost, right? So that
No.
that
Right now,
URI.
let's imagine Eureka server, it's not running. So our API gateway and booking service are not a part of Eureka server. So in that particular case, how I have to define this URI? I said this to you. I said this to you yesterday. Recollect it and tell me. So how we can actually call a service, basically the booking service? Can you tell me that? Come on, Suresh. Don't get confused. Yes. So here, if Eureka server is not there at all, okay. So HTTP :/localhost 8080. Very simple, right? That's all we do. Correct. And this bookings and the URL will be taken care by this service itself. Okay, so basically it will append /bookings and /test. Whatever. See, this is just a predicate to identify the incoming URL. What is the incoming URL? If you just see over here, /bookings /test. So this URL is actually matching with this predicate. So basically what it will do, it will append this /bookings /test to this API like this, and it will make a call to the booking service endpoint with this endpoint URL. So this is how it is going to run or work in the real time. Bookings and /test. Got it? Let me resolve your question now. So right now, let's say Eureka service is not there. Okay, correct? So how I have to call the payment service from the booking service? Suresh. This is just to resolve your question because you have
we have to use the port number, right? Because every
URL equal to HTTP :/localhost 9090. That is, and /payments is already there, right? So this is but when the Eureka service is already there, right? So if basically we are going to if Eureka service is already there, this URL is not required because URL and all this kind of information is already there with the Eureka server, the port information on all those kind of things. Just the service name is important over here. That's it. Got it?
Yeah, correct. Yes.
Yeah. So now if you have any questions, you can ask. Anyone has any questions, you can ask right now. Suresh, did you get the API gateway flow?
Yeah, I got it. Yeah.
Okay, any confusions? Because this is the beginning, right? So many people will have confusions. If you have any confusions, you can ask them. You can ask them right now.
A circuit breaker, little bit I have to understand.
Yeah, sure. I will definitely explain that to you. Yeah. Well, so here, let's say right now I just wanted to rebut everything. Yeah. So yes. So here, let's say right now, imagine we do have 20 services. So for 20 services, we will be having 20 route IDs, correct?
Yes.
So each and every route ID has to be unique. So in the ID, basically we will be giving the service name. Here, we can also give the service name. That is not a problem, first of all. Okay. So you can also give this ID as booking service, because ID here is a unique one. We don't have to define the same route IDs, right? So here we can actually define the service name itself because service name is unique, right? So we can define the service name also. So ID has to be unique. Okay. And then URI means which service it has to trigger. And the predicates is the place where we actually define the service related endpoints. Since I have defined all the endpoints, post, put, get, delete, everything. Okay. Because if any of the services, if any of the endpoint is not working, I have to revert back to the end user with some message, right? So that's the reason for all the bookings endpoint, I just have to provide this response. That means if the booking service is not available, then this filter will get invoked. What are these filters used for? Okay, so these filters are useful when, if you just go to this, can you see this? API gateway is up and booking service is down, correct? So now when API gateway is calling the booking service with the service name, then Eureka server is going to provide information to the API gateway. Hey, API gateway, booking service is not available right now. Do whatever you want from your side. So right now, we cannot give some unknown error messages to the end user, right? I just have to give some positive response. Right now, if you see the status as 500, right? If 500 status is coming, that is the internal server error, correct?
Yes.
Yeah. So when there is an internal server error, the application itself will not respond first of all, correct? So we need to make API gateway responsive. So if you just see, when I have opened the Book My Show, I was unable to, Book My Show was open, correct? Book My Show application is up. bookmyshow.com/movie ID and the movie I selected, correct? When I click on 7:30 a.m. show, did you see that? Suresh?
No.
No. So let me go to this Book My Show. Can you see this one? If I just select this, see here.
Say sorry.
That means.
Something.
So right now, Book My Show application is already available to the end user. The Book My Show can never go down. First of all, now each and every theater is like a service for the Book My Show. So now when I'm clicking on a certain theater with some show, it was unable to respond because the theater itself made their server down. That theater server is not responsive. That means it was not enabled to respond. So Book My Show has to show some data to the end user, right? What is happening behind the scenes, correct? So here Book My Show itself is acting like an API gateway and it is actually giving some default response to the end user. Now let's say what happens if I just click on the show name like this. And if it is not giving this error, then probably if 500 status, internal status error will come, then probably in that particular case, the whole Book My Show application will crash. Got it?
Yes. So do you have to give any timeout? Let's say
Yeah, that
we
is
don't
also
know.
there. No. See here. So right now, just trigger on this. See, every API, if it is not responsive, we can also give timeouts, but timeout is not the solution for this, Suresh. Because why timeouts are not required? Because some
We don't
services
know.
are still up. See, some services are up, but actually their servers are getting taking more time. See, even I have booked a ticket yesterday. It was almost taken me to the payment screen after 1 minute of time. We cannot give the timeout because that is a successful response, right? See, the request is successful, right? We are actually going to get an update from the server. We have to wait for it. If you are going to give the timeout, that's fine. If you are going to give the timeout, that is fine. But it it is applicable only for some services where we actually give the timeout, correct? So if you are not going to give those timeouts, then probably see for the payment service, we need to wait for, see, let's say I just wanted to submit my credit card details, internet banking was there, I have submitted the amount and I have entered the OTP. So I cannot refresh my browser, correct? It has to wait for the time until it gets a successful response. Otherwise, our booking will be failed and our money will be lost, but that amount will be credited back to us. That is a different way. But timeout is not an option for this particular reason. Got it?
Yeah, got it.
Yeah.
And
one more
LB.
thing. No. Let me tell you and the complete point. So here, let's say this circuit breaker is continuously giving booking services in maintenance mode. Please try after some time. And the users are actually hitting our API gateway in such a way that there are so many people who are hitting the API gateway, correct? We cannot allow the user to hit this bookings API more than 3 times. We can avoid that. So we can introduce that kind of things by introducing something called rate limiter. So this is really helpful. Whenever your server is down for a specific period of time, we cannot allow the users to continuously hit API gateway. Why? Do we have to allow the users? No, right? If the services itself is not out, why we have to waste our resources of the API gateway, correct? We don't have to respond to the user, right? So there is something called, if you just go to this introduction, so after the circuit breaker, this is just used for fallback mechanisms. And there is something called a rate limiter, which is being used for rate limiting. That means how many times I can call an API. Okay. What are the limits? Instead of giving a timeout, we can actually give the limits. Okay. And there is something called a retry. So retry is also, or bulkhead. So there is a bulkhead filter also. We can actually use it over here. Bulkhead, something like this. Okay. But we'll come to this later, but not right now. So this is where API gateway handles all the scenarios for all the services. And this is a single entry point, and it has to handle all the situations like the fallback mechanism using circuit breaker, how many times the user has to hit the API gateway, how to limit the rate of request or the number of requests that the user is going to send, and all these kind of things. Got it? So that is the advantage of using Spring Cloud API Gateway. If you have anything in your mind, please ask it, Suresh. I will explain as many number of times I can, but
so can we redirect?
Important.
Can you redirect as well? Like instead of giving this
forward
message?
Is just a forward is just a redirection.
Oh, okay.
Yeah.
And LB is like it's a load balancing that we use LB, right? It internally takes care of.
So here, let me tell you about this, right? So I just wanted to keep HTTP right now, okay? So if I just go and stop this API gateway for now and run this API gateway application, okay? Since API gateway has a registration with Eureka server, right? Since it is being annotated with this, if you just see this form.xml. So here we do have a Netflix Eureka client. So it will do the registration with Eureka server at any cost, correct? So now, if you can see that here, it has started, but I'll tell you what happens if I hit the application now. So let me go and hit this application. And here in the API gateway, you'll get the same thing, but the load balancing will not be done because let me tell you what happens. So here, whenever we do HTTP, Eureka server understands from the API gateway doesn't want to load balance the booking service. If 10 requests are coming, 10 requests has to be served by single instance. But if there is a LB, then Eureka server understands that I can have n number of booking service instances, and I can pass 2 requests to one service and 2 requests to another service instance of the booking service. So that's the advantage of using LB, which is a load balancing. Got it?
So one port, let's say, yesterday's example, you are getting one port, there will be 100 requests coming, right? So those requests, so same, how do we simulate that? So that means like same.
That will be
same
taken care
port.
by the Eureka server, right? So let's say I just wanted to start a booking service application 1. There is a booking service application instance 2 also, right? Let me start about that. Let me start that one as well. So booking service application, this is the instance 1, right? Correct? So now I just wanted to start another instance like this. So in real time, we will not be creating these instances. We have something like a Docker containers, which we will be using it. So here I just wanted to create another application. I just wanted to name this as a booking service application 2. And now I just wanted to select the IDE module is this booking service. And then I can select the booking service application as the main application. And here, I just have to start server.port on 8081 because 8080 is already taken by another booking service instance, right? Correct? So now I just have to start this on server.port 8081. Now I just wanted to start it 8081. So now another instance is starting. So let's wait for some time.
But if you want to use the same port and multiple requests coming on the same port,
same port, how it will work? It will not work, right? If the port is already taken, it will never start because that port is already in use, right?
Okay, so in that case, we have to use different port,
See, same. Say, if you have a domain, can you use the same domain for you as well? See, there is Amazon.com. No. Can you just answer my question? Are Baba, just answer my question, Suresh, first of all. If there is a domain existed already, Amazon.com or let's say EPAM.com, can you create your website with the same domain?
No, impossible.
Yeah, same port is also like that. Port is basically used to identify a service, right? Domain is also used to identify the company or organization. The same thing. So let's see this Eureka server now. So now if you see that, so right now we do have 8080. So let me go and so this is started on 88. So my booking service application 2 has not been started. So let's start this application. And now let's see what happens. Yeah, thank you, Akash. Yeah. So now let's say if I just refresh this now, can you see this?
Yeah, it's a different port.
Okay. So now Eureka server will take care of whether 10 requests are coming at the same time to the API gateway. So API gateway, when it calls the booking service with 10 requests, Eureka server will take care of whether the request has to be passed to this instance or instance. So it will actually distribute the load. Whenever you do have LB over here, API gateway is actually instructing, hey, do the load balancing for the booking service if you have multiple instances with you, Eureka server. Okay, so if you have multiple instances, please do the load balancing for the booking service because there is a huge load coming in for you. Got it? And also, in order to explain your question, I'll just go to this booking service API, and here I just wanted to do a sysout.
Print the port number.
Yes. So how I can actually get the port number? So here we do have something like private. There is the environment. Sorry, not this one. This is actually from the Spring framework. Okay. So this environment is basically from the Spring. Okay. So here I can actually use environment. I can actually do the auto-wired annotation on top of this. And here I can just use environment dot get
port.
Get property of. So I can actually define this server.port. That's it. Okay.
Okay.
Or I can just simply append something to this so that something will be printed test. just to see whether two logs are actually printing those things or not. So let me clear this one as well and clear this one as well. Let me stop and restart this. Let me stop and restart this. So let's clear all the logs and also restart the booking service application too. You don't have to worry about the load balancing. Eureka server will take care of the load balancing. Got it? So these servers are basically designed for that particular scenarios. Let me
So
clear
if
the
the
logs.
same if the same request is sent by 10 different users, so that means there will be 10 different port. Is that correct understanding?
No. Requests, 10 requests. Right now, how many servers are running for booking service? Only 2, right? These two services will take 10 requests parallelly. That means booking service application instance 1, which is running on 8080, it will take 5 requests and distribute another 5 requests to booking service application 2, which is running on 8081. So it will actually distribute the load of the request to the available number of instances. Yeah, that is something called a load balancing. Okay, so now if I just wanted to hit this multiple times, let's wait for some time because the Eureka server will take some time to actually make this booking service available for the API gateway after some period of time. So let's wait for some time and clear this logs and also clear this logs. So let me go and see whether everything is fine. So the services are up. And now if I just wanted to hit this endpoint, I just wanted to hit it multiple times. Let's wait for some time because it takes a lot of time to make it up.
So each hit represents the one request, correct? 10 times if you hit the same.
See, 10 times. See, I just wanted to refresh it parallel times. Okay. So that's the total idea. Where this is not up. Something wrong with our configuration. Let me go to the API gateway. I didn't save it. Okay. 1 second. So let me stop the application of the API gateway. And let me restart this. Okay, so this is how the load will get distributed between the available instances. Okay, so that's what it does in the background. Right, so I'll just refresh it multiple times. I have hit multiple times over here. Let's go to the booking service. Whatever. So here, this is also called, and see here, this is also called. Why this is not working over here? Booking server.port. Oh, okay. Maybe I was inside the booking service. See, here why it is actually calling null test and why it is actually calling 8081, because if you just see the naming convention, sorry for that. So here in the booking service, I have actually given small server.port. Okay, and I was getting capital server.port. If I just go to this edit configurations of the booking service application, I've just given it as capital port. That's why it is printing. And for the existing server.port, which was running by the booking service, it is actually small server.port. Okay, so it was not able to recognize that. Okay, so if you just go to this booking API, so we are actually calling this server.port. Okay, so here if you can see that I have submitted multiple requests. Some requests are being handled by this server and some requests are handled by this particular server. Got it? So many requests I have replied. Yeah, so that's how the load balancing will be done by the Eureka server. And the API gateway will tell the Eureka server whether it has to do the load balancing or not through this particular LB feature. That's it. Got it?
Yeah. Another simple question I had, like if
Yeah.
you want to simulate this through browser, right? So there
Yeah.
session management will come into picture, right?
See,
So
whenever
there
we are
like
working on microservices, there is no session management. Okay, so all those
okay,
are
when
stateless
your UI,
applications. See, microservices are basically designed for stateless applications. Monolithic applications are designed for session management applications.
oh, okay, there is no
Okay,
session management.
since why there is no session, because we'll be using JW2 token, OAuth2 token, or we'll be using some third-party APIs in order to authenticate ourselves. So that's why there is no session. We will be using token mechanisms to handle the sessions. That's it.
But browser cookies and all, you want this in this case?
Not
Because
required in microservices, because if you just
okay,
ask me truly, when you enter into the gmail.com, right? So when you enter into the gmail.com, I can call n number of services over here. I can go to the YouTube, I can go to the maps, I can go to the chart, I can just go to the drive. So once this Gmail is signed in, for existing drive and other applications also, it will say it will use the same token in order to authenticate. It doesn't need a session. Got it? So these are stateless
it's more
sessions.
secure. Yeah.
Yeah,
Okay,
right.
got it.
Yeah. Okay. So that's the total idea. So you'll come
Thank
to
you.
know when we are actually discussing about the Spring security part. There you will come to know about this mechanisms. Okay.
Yeah, thank you.
Yeah. Thank you so much. And I'll just go and open this in an Explorer, and I'll just compress this file, and I will just give it to you. You can also do whatever the testing, and Akash Wale, you can also do that experiment of the payment service, whether it is being called or not. But don't think that booking services in maintenance mode is continuously coming, because Eureka server will take some time to understand whether the service is not is up and running or not. So Eureka server will take some time to make the service up completely until it is live. Got it? So just wait for some time. Don't think that the service is not up. Okay. So Eureka server will take some time to make it up. Yeah. So now what I can simply do, I can simply go to this one, and I can just go to the Telegram. Sorry, not Telegram. So now I'll just go to this Java real-time project, and I'll just attach a file, and I'll just go to this desktop workspace, Srinivas, Naresh IT, real-time batch 2, and there you go, send it. You can just have a taste of it, and probably everything will work out for you. Okay, so that's the end of the session. And Naresh, what?
Hi, sir.
Yeah.
If booking service having some properties, payment service don't have those properties. How
Right.
payment service get booking service properties, sir?
Config server. I have not explained you that, right? So there is a config server provided by Spring Cloud to manage centralized configuration properties for all the services. Got it?
Oh, in future you will explain those topics, right?
You don't want me to explain, or how it is like?
Please explain. I want to know it, sir.
I will explain. Okay, don't worry.
Yeah, and one more. How microservices call each other and how many ways, sir? But
There
you
are
explain. Can you
different
show
ways
it
of
again?
communication. Right now, we do have REST template, Naresh. So REST template is basically deprecated, but we do have a recent version of REST template, which has advanced features. So REST template is another way. And since Spring Cloud itself provides some load balancing feature, that's the reason I'm using Paying Client. If you are using REST template, then you need to load balance on yourself by writing some extra code. Okay, and there is another client call, which is web client, provided by the Spring reactive programming. So we can use web client also in order to make a call. Got it? So these are the only ways of communication, and these are all synchronous communication. And there is something called asynchronous communication between the services that are not HTTP calls. These are basically going to use Kafka in order to communicate between the services automatically. We'll just see that. Okay, these are the only ways of communication. Synchronous and asynchronous mode of communications will be there between the services.
Yeah,
Got
that is
it?
basic. Right? See, we are writing these microservices are many microservices we are writing in the single project. So we have to know the how we can call microservices each other.
What do you mean by single project? What do you mean by
like
single
like
project?
like one applications dividing into multiple smaller applications, sir.
Right,
Each
right,
application
exactly.
having some. So if you want to call application A to application B, so we want
Hmm.
to share the data, those things. So
Right.
basic. We are following the which microservice design pattern, sir. This project you are explaining, right? This
Okay.
is Saga
So
design or what? Which design
see,
pattern?
this looks like a Saga pattern. This is a Saga pattern, of course, because booking service has its own database, right?
Yeah.
Payment service has its own database, correct?
Yeah. Yes.
So this is something called a database per service pattern, which is a Saga pattern. It comes under Saga pattern.
So if each service having separate database, we can say that is Sega pattern.
No. It's not the kind of way that I'm telling you. Right now, if you just see, API gateway is calling the booking service automatically, correct? With the
Yes.
paying client. Now, booking service has to call the payment service. That communication does not has to be a synchronous communication. See, payment service will be down for some period of time, correct? The
Yes.
moment it is up, it is going to lose the request, right? So that is not a way where booking service has to call the payment service. There has to be a asynchronous way of communication. Even when the payment service is down, when the booking service, let's say it has 10 requests within it, and it was unable to call the payment service, let's say the payment service is up after some period of time, it has to process the 10 requests, right? In that particular case, we need to go for asynchronous mode of communication. The moment the payment service is up, whatever the requests are lost, we'll just keep them in a topic, and then we'll proceed processing the topic messages, and we'll just insert them into the database. That is how this asynchronous mode of communication will come.
Okay.
We have to
Sir,
do that using Kafka.
you has to do that with Kafka. Yes.
Until unless how we can be able to, first you need to understand all these kind of things. How I can right away go to the Kafka and I explain you'll not be able to understand anything.
Yes.
Any other questions?
So you are explaining this project, sir. Do you have any architecture diagram of this project, sir? You are explaining to us, right?
I already do have a architecture, correct, my friend.
You shared it, right? Sorry,
Yeah,
I'm missing
I
some
already
classes.
shared it.
Okay.
You can see in the Telegram channel, it will be there. Okay.
Sorry. I'm missing nowadays some classes. Sorry for that.
If you are missing any of the classes, but don't miss Kafka. Kafka, there will be a huge in-depth explanation. They will be explaining a very good use cases for Kafka as well. Okay, you'll try to understand the Saga design pattern also, where if if we need to change the database transactions in a distributed environment, because each and every service has its own database and they have to revert back the transactions, how we can actually do that, right? So we will see all those modes of communications over here. So don't miss the classes.
Yes, sir. Each service having separate database.
Don't
How we
repeat the
can
question again.
no,
Don't
how
repeat
we
the
can
question.
maintain the data consistency kind of stuff.
Did I come to Kafka first? Did I come to Kafka? Then why you're asking this question now?
I don't know. Just want to know. Just
You will come
I'm
to know
doing.
when the topic comes, right?
Yes.
If I just say it to you, you will not able to understand. I'm sure pretty about it. Do you know group
Yes.
ID in Kafka, first of all? Do you know group ID in Kafka? Do you know offsets?
Group ID.
Do you know
Group ID.
clusters?
Sorry.
Do you know clusters?
Clusters. Clusters a little. I have clusters we have
Okay.
in.
Do you know about offsets?
No, I don't know.
Do you know about group IDs?
Group ID. Each Kafka having a separate group ID.
Okay. What is that group
Topic.
ID?
I'm not in detail. I don't have in detail idea.
Asking this question doesn't asking this question doesn't make any sense, Naresh.
Okay.
Wait for some time. Just go with the sequential flow, man.
Yeah, I agree with you. Sorry, some days I'm missing the classes. So
I know
maybe
that you want Saga pattern, but the Saga pattern will be completely different. You will not find it any of the Google articles or Udemy or YouTube tutorials. I'm damn sure about it. Got it?
Yes, yes, yes.
The way I just wanted to develop this application is in a different path. You will not
Okay.
find this type of applications anywhere. If you just find any of these applications like this in Google, in any of the articles, ping me directly the URL.
Sure, sir. I'm happy with that your sessions.
You are
Just,
happy. You are happy. Let's wait for some time, Naresh. Okay.
yes, yes, sir.
Don't do hurry or things. Okay. Yeah.
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 Yes, yes.
That's all.
Okay, thank
Yeah.
you.
Okay. Thank you and have a great day and happy learning. So try the application zip, which I have given it to you, and tell me if you are facing any issues. Okay. So have a great day and happy learning. Bye.